Today we will continue exercise 3.3 from integration by parts. This is our third lecture, and the first problem is integrate the following with respect to x, e raised to 2x into sine 3x. So let I is equal to integration of e raised to 2x into sine 3x. Now here if this is exponential function and this is trigonometric function. So using LIATE rule, first function is a sine 3x and the second function is e raised to 2x. So use by parts. The first function is as it is, integration of the second function minus integration in bracket derivative of the first function into integration of the second function. Therefore I is equal to first function as it is, integration of e raised to 2x upon 2 minus the derivative of sine 3x is 3 cos 3x, and integration of e raised to 2x is e raised to 2x upon 2 dx. So 1 upon 2 e raised to 2x into sine 3x minus 3 upon 2 integration of cos 3x e raised to 2x. Now here again this is an here you have to use by parts rule. So let this is I1. Again the I1, in I1 you have to use LIATE rule. So first function as it is, the integration of the second function minus d by dx of the first function into integration of the second function. So after finding the integral, again I am getting the integral sine 3x e raised to 2x, but this is our original I from where we have started. So let this be an I. So we will put the value of this I1 in our first equation. So then multiply this integral by 3 by 2. Here you will get minus 9 by 4 I. Take this to this side, take their addition, you will get 13 upon 4 times I. Now multiply this equation throughout by 4 and divide by 13. You will reach to this step. Okay, so 4c1 upon 30. Here 2 2s are 4 and 4 4s are cancel. We can take e raised to 3x 2x common. E raised to 2x upon 13 in a bracket 2 sine 3x minus 3 cos 3x plus c, where c is equal to 4 upon 13 c1. So this is the integral of the given function. Now integrate this function e raised to minus x into cos x. Again, it is the first function is an exponential and the second is trigonometry, so which is not in LIATE rule. So we have to write it in a proper way. So the first function must be cos 2x and the second function must be exponential, because exponential function is at the last. Okay. So use the by parts theorem. How now? You know how to use the by parts theorem. First function you have to keep it as it is. Then integration of the second function minus integration of derivative of the first function into integration of the second function. So integration of e raised to minus x is e raised to minus x upon minus 1. Then derivative of cos 2x is minus 2 sine 2x. So after simplifying, you will get minus e raised to minus x cos 2x minus 2 times I1, where I1 is the integral of sine 2x e raised to minus x. Okay. Again, for this integral, we will use the by parts theorem. First function as it is, integration of the second function minus integration of derivative of the first function into integration of the second function. So I1 is equal to sine 2x into e raised to minus x upon minus 1 minus integration of 2 cos 2x into e raised to minus x upon minus 1 dx. So here uh, you will get an integral cos of 2x e raised to minus x dx. This is our original integral. Okay. So we will put for this integral I will put I. plus C1. Now, this using this I1 in equation number 1, we get this equation. Multiply this bracket by 2, then this minus 4i will come to this side, and I plus 4i is 5i. Then divide that 5 to the right hand side. You will get minus 2 upon 5 times C1. We will replace it by C. So it is I is equal to e raised to minus x upon 5 in bracket 2 sine 2x minus cos 2x plus C. Integrate the following with respect to x. Sine of log x. Okay, so let I is equal to integral of sine of log x dx. So put log x is equal to t. So 1 upon x dx is equal to dt. So dx is equal to x dt. And this x we can write it as e raised to log of x to the base e. Okay, how to write this x? This x I can write it as e raised to log of x to the base e, and log of x to the base e is already we have put t, so x can be written as e raised to t. Sin t e raised to t dt. Now use by parts. Sin first function as it is, integration of the second minus integration d by dt of the first function, integration of the second function. So sin t e raised to t minus integration of cos of t e raised to t dt. So sin t e raised to t minus integration cos t as it is, integration of e raised to t dt minus integration of d by dt of cos t integration of e raised to t dt into dt. So after finding the integral, we will get I is equal to sin t e raised to t minus in curly bracket cos t e raised to t plus I plus c. That is sin t into e raised to t minus cos t into e raised to t minus I plus c. This minus I will come to this side and we will get 2i, and we can take e raised to t common from these two terms. So in next step what we will get, e raised to t upon 2 times sin t minus cos t plus 1 upon 2 times c1. So this 1 upon 2 times c1 is nothing but c. But what is t? T is log x. So use instead of t log x. So e raised to log x upon 2 sine of log x minus cos of log x plus c. But e raised to log of x to the base e is nothing but x. So x upon 2 sine of log x minus cos of log x plus c. Square root of 5x square plus 3. Let I is equal to integration of root 5x square plus 3 dx. So I is equal to integration square root of 5 in bracket x square plus 3 by 5 dx. Okay, we can take this 5 away. Root 5 integral of root x square plus root 3 by 5 bracket square. So it is in the form of root x square plus a square. And the formula is standard integrals using by parts. So x by 2 root x square plus a square by 2 log of x plus root x square plus a square. Use that this formula. uh, Here a square is nothing but root 3 by 5 bracket square. So use this formula, you will get the answer. Root 5 into x by 2 root x square plus 3 by 5 plus 3 by 10 log of modulus of x plus root x square plus 3 by 5 plus c. Now look at this example. X square square root of a square minus x raised to 6. Now here I can write this x raised to 6 as x cube, it's a square. Then I will use the substitution for x cube is equal to t, that is 3x square dx is dt. So x square dx is dt upon 3. So this x square and this dx both will replace by dt upon 3, and in will get in root a square minus d square. So we take 1 upon 3 common, integration of root a square minus t square. Its integral is given by t by 2 root a square minus t square plus a square by 2 sine inverse of t by a plus c. So 1 upon 6 square bracket t root a square minus t square plus a square sine inverse of t by a plus c. Root x minus 3 into 7 minus x. Let I is equal to integration of root x minus 3 into 7 minus x. Now we can take the multiplication of these two factors so that we will obtain the quadratic factor. Then make we completing the completing square method, or for making the perfect square of this equation, you have to add the term 25. So add and subtract 25. 25 minus 21 is 4, and x squared minus 10x plus 25, I can write it as x minus 5 bracket square. So again I get the integral of the form root a square minus x square. Its integral is x by 2 root a square minus x square plus a square by 2 sine inverse of x by a plus c. But here x is x minus 5. So this is the integral of the given function. Now look at this seventh example. Root of 4 raised to x into 4 raised to x plus 4. Okay, this 4 raised to x, I can write it as 2 raised to x, it's a square, so that I can take this common from this root. Outside the root it will become 2 raised to x. Square root of 2x root raised to x bracket square plus 2 square dx. Now use the substitution. 2 raised to x is equal to t, so its derivative is 2 raised to x log of 2 dx is equal to dt. So 2 raised to x into dx is equal to dt upon log 2. Therefore I is equal to integration of t square plus 2 square dt upon log 2. Therefore I is equal to 1 upon log of 2 integration of t square plus a square. So 1 upon log 2 t by 2 root t square plus 4 plus 4 by 2 log of modulus of t plus root t square plus 4 plus c. Okay, but what is t? T is nothing but 2 raised to x. So we have to again substitute 2 raised to x here. This 1 upon log 2, 2 raised to x upon 2 into root 4 raised to x plus 4 plus 4 upon 2 log of 2 raised to x plus root 4 raised to x plus 4 plus c. This is the solution of the given problem. Now the next problem is x minus 1 root 2x square plus 3. So it is in the form of px plus q and root ax square plus bx plus c. So here we have to express this x minus 1 as a times d by dx of this 2x square plus 3 plus b. So comparing the like terms, you will get 4a is equal to 1. So a is equal to 1 by 4 and b is directly minus 1. So I can write this x minus 1 as 1 upon 4 times 4x plus minus 1. So multiply this square root by this factor. Then here use the substitution. Here in first integral we will use the substitution. 2x square plus 3 is equal to t. So 4x dx is dt. So root t dt. So its integral is t raised to 3 by 2 upon 3 by 2 plus c1. So 2 by 3 in bracket 2x raised to 2 plus 3 raised to 3 by 2 plus c1. Also now the second integral is I2. I2 is equal to integration of root 2 in bracket x square plus 3 by 2 dx is equal to root 2 and square root of x square plus 3 by 2 dx. So here you have to use under root x square plus a square. What is its integral is given by x by 2 root x square plus a square by 2 log of x plus root x square plus a square. Using this formula, I get the integral 1 upon root 2 x root x square plus 3 by 2 plus 3 by 2 modulus of x plus root x square plus 3 by 2 plus c2. Okay, so using these integrals in equation number 2, we get 1 upon 6 in brackets 2x square plus 3 bracket raised to 3 by 2 plus 1 upon root 2 x root x square plus 3 by 2 plus 3 by 2 log of modulus of x plus root x square plus 3 by 2 plus c, where c is equal to 1 upon 4 times c1 plus c2. This example is also similar to that one only. Here this x we have to express, this x we have to express as a into derivative of this 5 minus 4x minus x square plus b. So x is equal to a times minus 4 minus 2x plus b. Multiply this bracket by a. You will get minus 4a minus 2ax plus b. So minus 2a is equal to 1 and b is equal to 0. Minus 4a plus b, minus 4a plus b is equal to 0. So b a is equal to minus 1 upon 2 and b is equal to minus 2. So I can write this x as minus 1 upon 2 times minus 4 minus 2x minus 2. Multiply the square root to this bracket and then simplify. I1 and I2 in first integral use the substitution. 5 minus 4x minus x square is equal to t. So minus 4 minus 2x dx is dt. So root t dt. So t raised to 3 by 2 upon 3 by 2 plus c. So 2 by 3, 5 minus 2x minus x square raised to 3 by 2 plus c1. And for the second integral, completing the square, you will get 3 square minus x plus 2 bracket square. So here we will use the formula a square minus x square. Its integral is given by x by 2 root a square minus x square plus a square by 2 sine inverse of x by a plus c. So by using that formula, you will get this integral, and then using these two integrals in our equation, this equation I is equal to minus 1 upon 2 times I1 minus 2 I2, we get minus 1 upon 3 5 minus 4x minus x square is to 3 by 2 minus x plus 2 root 3 square minus x plus 2 bracket square minus 9 sine inverse of x plus 2 upon 3 plus c, where c is c1 plus c2. Now for this example, we have to use the substitution, and we have to put tan x is equal to t. So sec square x dx is dt. So we get a quadratic factor in the square root. Here we will use the computing square method, add and subtract 1 by 4. We get t plus 1 by 2 bracket square minus 21 by 4. I can write this as root 29 upon 2 bracket square. So here we get root a x square minus a square, and its integral is given by x by 2 root x square minus a square by 2 log of x plus root x square minus a square. So rewrite the step, simplify this 2 will get 2t plus 1 upon 4, and here 29 upon 8. Then we use t is equal to tan x that we have substituted before starting the example. So put t is equal to tan x in your answer, you will get the required solution. Now the next example, root x square plus 2x plus 5. Again here we have to make the completing the square method, complete it and use root x square plus a square formula. X by a, x by 2 root x square plus a square by 2 log of x plus root x square plus a square. So using this formula you will get the required answer. This is also on the same line. Firstly we have to take the 2 common from this factor. So you will get root 2 times integration of x square root of x square plus 3 by 2x plus 2 dx. Now here what we will do, again we have to complete the square by adding and subtracting 9 upon 16. How 9 upon 16? Because what is the last term we have calculated by 1 upon 2 times 1 upon 2 times minus 3 by, so resume this is 1 upon 2 times coefficient of x. What is the coefficient of x here? It is here 2 by 3 by 2 and it's a square. So you get 3 upon 4, it's a square, is nothing but 9 upon 16. So here we have to add and subtract 9 upon 16. So what you get, x plus 3 by 4 bracket square plus root 23 upon 4 bracket square. So you have to use root x square plus a square, x by 2 root x square plus a square by 2 log of x plus root x square plus a square. So just simplify this equation and try to write the answer. You will get the simplified form of this answer like this. Okay, now we will stop here today.